Greetings and welcome to Lesson 2.2. We're going to work with prime numbers, factors, as well as reducing fractions to their lowest terms. The first thing we should discuss is some language that I'll be using, some vocabulary. One is prime number. A prime number is any whole number greater than 1 that has exactly two unique divisors, itself and 1. So I said a magic word there, divisor, and a divisor is just a number that can divide another number evenly without a remainder. So let's choose a number, 2. Let's see, 2 is greater than 1, and it has two unique divisors, 2 and 1. So 2 times 1 will get me back to 2. But there's no other way with whole numbers to break apart 2. So 2 would be a prime number. Let's try 3. 3, well, 2 doesn't go into it evenly. So 3 is a prime number. 3 times 1 will get me 3, but there's no other way with whole numbers to get a 3, so 3 is prime. Next number, let's try 4. Well, of course, 4 times 1 is 4, but 2 times 2 is also 4. So 4 is not a prime number. It has other divisors besides itself, 4, and 1. It has the divisor of 2. So it is not a prime number. In fact, it is called a composite number. It's any whole number greater than 1 that is not a prime number. Well, 4 is not a prime number, so it's a composite. Now I've listed a few prime numbers out for you. These are good to kind of have in your, head, especially when we get to prime factorization. 2, 3, 5, 7. Now, if you're thinking every odd number is a prime, no, because 9 is not prime. Why is 9 not prime? Well, 3 times 3 is 9. So besides 9 times 1, it also has the factor, it has the divisor of 3. Therefore, 9 is a composite number. 11, 13, of course all even numbers besides 2, all even numbers are composite numbers because they have a divisor of 2 in it. So that's why I'm skipping over even numbers. 11, 13, 17, 19, 15 I skipped over because 5 times 3 is 15, as well as 15 times 1 is 15. 19, 23, 29, 31, 37, and so on. Prime numbers never end. They go on and on and on. So here's what we know. Prime number is greater than 1, and it has exactly two unique divisors, itself and 1. Now you might ask, what about 1? 1 is not prime because it does not fit the definition. 1 is not greater than 1. And it doesn't have two unique divisors. 1 times 1 will get us 1, but they're not unique. It's very clear that it's unique divisors. Let's take a couple of examples of numbers and try and figure out if they're either prime or composite. First of all, A, B, C, D. A is 43, B is 12, C is 51, D is 101. All of these are greater than 1, so at least we know they fit the 1 part of the definition. Now we just have to figure out how else can I break down the number. Will it be just itself and 1, or are there other ways of breaking down the number? So 43, let's think about it. Well, 2 doesn't go into it. We can try, but it's not an even number, so 2 doesn't go into it. 3, let's see if 3 will go into it. 3 into 43, 3 goes into 43 once, but 3 does not go into 13 evenly, so 3 does not go into it. 5 doesn't go into it because it doesn't end with a 5 or a 0. Next prime would be 7. Well, 7 times 6 is 42, and 7 times 7 is 49, so 7 doesn't go into it, and 11, that would be 3 times 11 would be 33. 4 times 11 would be 44, so 11 doesn't go into it. 13 doesn't go into it. So I can go all the way up the primes, but it turns out that 43 is indeed prime. All right, what about 12? Well, 2 goes into 12. In fact, we can break 12 down into 12 equals 12 times 1. 12 will equal 4 times 3. 12 will equal 2 times 6. And in fact, 12, if we broke it down into all primes, 2 times 2 times 3. So definitely 12 is a composite. Okay. What about 51? Well, let's think about this. 51. Well, 2 does not go into it because it's not an even number. But let's try 3. So can 3 go into 51 evenly? 3 goes into 5 one time, and 3 does go into 21 17 times. So 21 with no remainder. So let me erase that. So 51 will equal, of course, 51 times 1, but it's also 51 is 3 times 17. Therefore, 51 is also a composite. Okay. Now, what about 101? Let's see. 2 doesn't go into it. 3, we could try 3, but 3 actually does not go into it. There's a nice little trick with math. If you add up all the digits of 101, 1 plus 0 plus 1, that equals 2. 2 is not divisible by 3, therefore 3 is not a factor, is not divisible. The 101 is not divisible by 3. Well, 5 does not divide 101, 7 doesn't, 11 doesn't, 13 doesn't. So I can keep going and going, but as it turns out, 101 is also prime. Now you may be asking, when do I know when to stop? Well, if you get, let's say, up to 50, you've checked all the primes all the way up to the first one before 50, which I think is 47, then you're pretty safe that you've tried everything that might possibly go into 101. So you do want to go halfway, check all the primes halfway, and if those don't go into 101, then you can pretty much call it a prime. Now you've also heard me call something called a factor. That's the same as a divisor. And if you think about it, in our division, we have something that's the dividend over the divisor equals the quotient. Okay. So the divisor is on the bottom, and it will go into the dividend, and if it goes evenly with no remainder, our quotient will be a whole number, and therefore we say it's a factor of the dividend. Now, prime factorization is just the process of writing a composite number, or a prime number for that matter, into all of its primes, all of its prime factors. For example, we have, 108. Well, when we think about it, 108 is 2 times 54. Well, 2 is a prime. So 2 is already done in primes. Okay, so that's already a prime. So I'm just going to go ahead and highlight all of the 2 that we first found. Next, 54 is not a prime, so I want to break it down. Well, 54 is actually 2 times 27. So all of those 2's are taken care of with the 2 times 27. But 27 is not prime because 27 is 3 times 9. So that takes care of those 3's. And 9 is 3 times 3. So if we want to write out the 108 all in its prime, it's going to be 2 times 2 times 3 times 3 times 3. Or we can say 2 squared times 3 cubed. Now there's another way of showing this by a tree, and let me show you how to break it down in a tree. Another way of breaking down 108 is I want to show two numbers that multiply 108. Now I always start with 2. I look at the number, and if it's an even number, I do know 2 is a factor. So 2 times 54 will get me back to 108. Okay? Now 2 is done. 2 is a prime, so I don't have to worry about the 2 anymore. But 54 is not a prime number. Why? Because it ends in a 4, and 4 is an even number. So therefore I know it has a factor of 2. 2 times 27 is 54. That goes back up to 54. So again, 2 is prime. I don't have to worry about that anymore. But 27 is not prime. 27 is 3 times 9. So 3 times 9 will get me back up to 27. Just like 2 times 27 will get me back to 54, 2 times 54 will get me back to 108. So I'm down at 3 times 9 now, and 9 is not prime. But I can break down 9 into its prime components as 3 times 3. And last but not least, 3 can be written as 3 times 1. As soon as I get to a 1, I'm done. There's no way else I can break apart a 1. So here are my primes. 3, 3, 3, 2, 2. In other words, 2 times 2 times 3 times 3 times 3 will all get me back to 108 if I multiply all of that together. If I write it in exponential form, that's going to be 2 squared times 3 cubed, because I have 2 2's and 3 3's. Okay. Now I've also tried, and I've done the prime factorization with 60. Again, if you want to see it just written out as it grows, 60 is 2 times 30, but 30 is not prime. And because 30 is not prime, I have to break apart 30. Well, 60 now becomes 2 times 2 times 15. 15 is not prime, therefore 2 times 2 times 3 times 5. Since 2, 3, and 5 are all primes, I'm done. The only thing I need to possibly write it as exponential form, which is 2 squared times 3 times 5. Now, you may not have noticed that it was 2 times 30. Maybe you thought, oh, 6 times 10. Well, 6 is not prime and 10 is not prime, so you would have to break these apart separately. Okay, 6 is 2 times 3, and 10 is 2 times 5. And then I like to write it from smallest prime to largest prime. So 2 times 2 times 3 times 5. Same thing I got on the other way that I did it. So my final prime factorization would be 2 squared times 3 times 5. Now if you want to think about it as that tree method, so if we go back and I have 60, what two numbers do 60? Now if I'm not too sure, I know this is an even number. I always start with 2. 2 has got to be a factor because it's an even number. 2 times 30 will get me back to 60. Now I'm not done because 30 is also an even number. So again, it's going to be 2 times 15. And I have to stop and think, well, is 15 a prime? No, it's not. It's 5 times 3. So I can say 5 times 3. and then 5 is prime, but 3 is also prime. So I can just finish it off by saying 3 times 1. So my primes are 2, 2, 5, and 3. 2 times 2. Now I like to reorder it so it's from small to big, times 3 times 5. But that's the same thing as 2 squared times 3 times 5. So the prime factorization of 60 is 2 squared times 3 times 5. Well, let's change gears just a little bit and start talking about geometry. In this event, we're going to start talking about triangle, and specifically the area of a triangle. Now, the area of a triangle, we need two things. We need the length of the base, the measurement of the base, and we also need the measurement of the height. The measurement of the height is just going to be the peak of the triangle straight down to the base. The base is the bottom part of the triangle. And as long as I have that, the base and the height, then I can figure out the area of the triangle. And the area of the triangle is 1/2 times base times height. For example, if we want to find the area of a triangle with the height of 7 inches and the base of 10 inches, I'm going to plug in my base, where the B is, and my height, where the height is. So A equals 1/2 times base is 10 inches times the height is 7 inches. So this is just multiplication by fractions now. And if you need to write the whole numbers over 1, you certainly can. And 1 times 10 times 7 is 70, but inch times inch is inch squared. 2 for the denominators. 2 times 1 is 2. So now I have 70 inches squared over 2, but 2 goes into 70 35 times. So my area of my triangle is 35 inches squared. Now, why does this work? Well, if I put this triangle inside a rectangle, then here's what happens. And I'm just going to color the left-hand side here. And if you notice, the red line of the triangle cuts that rectangle in half. Okay? It cuts it in half. So I only need half the area of this rectangle over here. Likewise, the other side of the height of the triangle creates another rectangle, and I only need half of that portion of the rectangle. So really, a triangle is half a rectangle. And if my area of a rectangle is length times width, we can also think of the length as the base of my triangle and my width as the height of my triangle. But I only need half of that rectangle. Therefore, it is the area of a rectangle would be base times height, and the area for the triangle would be 1/2 base times height. All right, let's go back to fractions and think about lowest terms. A fraction that is in lowest terms if the numerator and the denominator have no common factors besides 1. For example, fractions that are in lowest terms would be 1/2, 1/3, 2/3, 1/4, 3/4, 1/5, 2/5, 3/5, and 4/5. All of those are in lowest terms because the numerator and the denominator have nothing in common. Fractions that are not in lowest terms would be 2/4. Now, why would 2/4? Well, 2 can be written as 2 times 1, and 4 can be written as 2 times 2, so they both have a 2 in common. Now let's think of 6/8. Okay. Well, 6/8, number one, they're both even numbers, so they at least share a 2 in common, so they're not in lowest terms. Okay, let's think about 10/15. Do they share any number in common? Well, 10 is 2 times 5, and 15 is 3 times 5, so they both have a 5 in common. Okay. 11/22. Well, 11 is 11 times 1, but 22 is 11 times 2, so they both have the 11 in common. And then another example would be 100/150. Now, as long as they have one thing in common, they're not in lowest terms. So let's see, 100 could be written as 20 times 5, and 150 could be written as 30 times 5, so they at least have a 5 in common. So what I think the easiest thing to do is use the power of prime factorization to be able to figure out what the fraction, the numerator and the denominator have in common, and then we can bring it down to its lowest terms. So if I take 12/15, well, 12 can be written as 2 times 6, and 15 can be written as 3 times 5. 6 is not prime, so I'm going to go ahead and write it as 2 times 2 times 3. So 2 times 2 is 4, 4 times 3 is 12. It does get me back to 12, over 3 times 15. But here's the thing. They both have a 3 in common. Okay, they have this 3 in common. So if I kind of line up the 3's on top of one another, and then say, well, the top is 3 times 2 times 2, and the bottom is 3 times 5, a 3 over a 3 is just a big fat 1, right? So I can factor out the 3 because it's a 1, and we don't really need the 1. That only leaves the 2 times 2 on top and the 5 on the bottom. So my final result in my lowest terms is going to be 4/5. Now let's look at another example. 126/165. When they're larger numbers, they're a little bit more difficult to figure out, so I like to write them out in prime factorization. So if I break apart 26/165, here's another way that I can do it. Okay, so let's get my handy dandy pen here, and my numbers are 126 and 165. I want to break these apart. I'll do 126 first. Well, definitely 2 goes into it. I am always a start with a 2, go with the smallest numbers, and build up. 2 can go into 126. 2 goes into 12 6 times. 2 goes into 6 3 times. Well, 63 is an odd number, so I know a 2 will not go into it, but let's try 3. 3 will go into 63 21 times. I do know 21 is 3 times 7, and 7 is prime, so that's 7 times 1. So my primes for the 126 will break down into 2 times 3 times 3 times 7. Now the 165. Definitely 2 doesn't go into it because it's not an even number. I'm going to check 3. You may see there's a 5 in there. I'm just going to go with 3. 3 goes into 16 5 times with 1 left over. 3 goes into 5 5 times. All right. So 3 times 55 will get me back up to 165. But 55 is 5 times 11. And 11 is prime, so I can write 165 as 3 times 5 times 11. All right. So now how can I write this fraction? 126/165 will equal 2 times 3 times 3 times 7 all over 3 times 5 times 11. But they have a 3's in common. Well, a 3 over 3 is just a big fat 1. Therefore, we can cancel those out. That leaves me with 2 times 3 is 6, 6 times 7, is 42. 5 times 11, 55, and I'm done. Okay. So let me scroll back up. 42 over 55 will be the reduced fraction. Now let's take another example. So 294 over 693, and it's actually a negative 294. I don't want to forget about that negative. It has to go along for the ride. All right, so let's break down 294. Definitely 2 goes into it. 2 goes into 2 once, 2 goes into 9 4 times with 1 left over, 2 goes into 14 17 times, or 7 times, pardon me. All right, so let's see. I don't know off the bat, but I'm going to try a 7. So let's see 7. 7 goes into 14 2 times. 7 goes into 17 1 times. Pardon me. Okay, so I do know that 7 times 21 will get me back to 147. And 21, nicely enough, is 7 times 3, and 3 is 3 times 1. So I can break apart 294 as in, let's see, 2 times 7 times 7 times 3. Or if you wanted to write it in high to low or low to high. All right, 2 times 3 times 7 times 7. Now, 693. Let's break it apart. Well, 2 doesn't go into it, but 3 does. 3 goes into 693. 3 goes into 6 2 times. 3 goes into 9 3 times. 3 goes into 3 1 time. Well, now I'm a little bit stumped, so I'm going to try a 3. I don't know. Let's try 3. 3 times, well, 3 goes into 2 none times, 0 times. 3 goes into 23 7 times. 3 goes into 21 7 times. Oh, good. So 3 did go into it. There's another trick. Add the digits. If it's divisible by 3, then it's divisible by 3. I just didn't use that trick. 77 can be written as 7 times 11, and then 11 is prime. So I can write 693 as 3 times 3 times 7 times 11. So now I have to figure out what they both have in common. So a negative 294 over 693, well, if I write it in their primes, 2 times 3 times 7 times 7 all over 3 times 3 times 7 times 11. Whatever they have in common, they both have a 3, those cancel out. They both have a 7, those cancel out. So I am left with 2 times 7 is 14, 3 times 11 is 33. I almost forgot the 294 was negative, so I do have to make, pardon me, the 14 negative. You can't just forget your negatives. So just a little bit more for this lesson. Let's start applying this concept. So Laura is having a party. She puts 4 6-packs of diet soda in the cooler. At the end of the party, she finds only 4 sodas have been consumed. What fraction of the sodas are left? And we want to write it in lowest terms. First, we need to know what the total number of sodas are. 4 6-packs. It's going to be 4 times 6, so we have a total number of 24 sodas. And we do know that 4 of them folks drank. So that's 4 out of 24. So we drank 4 out of 24. Or we can think of it as 24 minus 4 will all out of 24. So that would be 20 sodas left. But we want to know how many are consumed. So what proportion of the sodas are left? So that's 20 out of 24. 20 we can write in its primes as 2 times 2 times 5. And 24 can be written as 2 times 2 times 6. They both have 2's in common. So we can cross those off, leaving us with 5 over 2 times 3, but that's 5 over 6. Now, you might be able to just kind of leave it without going all the way down to the primes. If you just see that is what they have in common, then you can stop there. My thing is I usually try and do it down to all the primes just in case I miss something. So let's try to reduce 4/40ths into lowest terms. And this time I'm not going to use primes. I'm just going to use my logic by math that I know. Well, 4/40ths. 4 can go into 4. That's 4 times 1. And 4 times 10 will get me 40. Therefore, 1/10 will be my reduced terms, my lowest terms. Now let's try negative 105 and 30. Well, negative 105 and 30, I do know 30 is 3 times 10. And let's see, negative 3 times, that's 35, will get me 105. But 35 and 10, we can break those down even more because they have some things in common. So I'm just going to go ahead and cross off those 3's right now. 35 is 5 times 7, and 10 is 5 times 2. Okay. So the 5's can go away. So I am left with negative 7 over 2. And it's okay if you want to reduce as you go. Just don't reduce too much. Just want to get it down to the lowest terms. So that's it for this video. Until next time, be seeing you.